Welcome to my lab 2 for Physics 2212, the lines of charge. So for our introduction, we were going to be using our calculations and data from lab 1 in order to create a more sophisticated model for finding the electric force. And we were going to be doing that by, instead of treating the tape as point charges, we would treat them as a line charge. And this would help us to get a far better estimate of the charges. And we would end up having to find an estimate for Q in order to approximate and get our electric force and gravitational force to be equal to each other. For our final results, we found that the magnitude of Q for the force of gravity and electric force would be 2.58187 times 10 to the negative 8 coulombs. So for our concepts and principles, more or less of the same of what happened in the first lab, we would be using Newton's second law, and we would be using it by saying that F net would be equal to 0. And by that, our only two forces acting upon each other would be the gravitational and electric force, one acting in the positive y direction and one in the negative y direction. We would also be using Coulomb's law, and then we would be using Newton's third law, and these two vertical forces would be equal in magnitude and opposite in direction. And here it would be our electric force and our gravitational force. So our experimental setup was the same. We would still measure out the tape, and we would make a handle and we would stick it to the surface. We would attach a U-tape to another one and create a charge. We would then hover that charge over in order to create a force. So for the assumptions that we made, we would treat the long tape as though it were a point charge, and we would have all the charge concentrated at the center of the long tape. We would also assume that each U-tape had the same amount of charge and they were all distributed evenly along the tape. And this would make it seem like it was line charges instead of a point charge. We would also be ignoring any air resistance that would be acting upon our moving object. So for our glow script code, we found our physical constants, and we used the same constants that we had from our previous lab with our mass and our tape length and our distance. On line 17, we had to find our Q estimate. And by doing so, we would have to run the lab several times in order to see the magnitudes of our electric force and our gravitational force. And we would have to change our estimate of Q in order to get a far better accurate estimate of what the charge of our Q should be. We also defined our electric field, and we defined our line charge as well. On line 60 down below is when we started accounting for our electric force on top due to the bottom tape. We would also change our scale in order just to make the arrows look nicer. And then at the very bottom, we printed our magnitude of our electric force, our magnitude of gravitational force, and then we printed a comparison of the model Q that we found from our first lab and our computational line charge model Q that we found from doing the estimates. So here for our computational model, you can see that we have our model showing the line charges and the distribution of the E field. It's evenly distributed along the points. Our purple arrow going downward represents our gravitational force, while the white arrow represents our electric force. As you can see from the writing down in the bottom, that the magnitude of them are equal to each other, and they have a magnitude of 1.962 times 10 to the negative 3. And we found this by playing around with our Q estimate, and we ended up finding that our estimated Q to make this happen to each other would be 2.58187 times 10 to the negative 8 coulombs, not negative 3. And the magnitude of the electric force and gravitational force are equal to each other. So for our reflection questions, what if you had modeled each of your tapes as a single point charge like the previous lab? Well, if we did that, then we'd find that our Q would have been the same. It would have been equal to 1.07388 times 10 to the negative 8. However, we find that our value is now 2.58 times 10 to the negative 8. So there is some disparity between the two, but the value of Q is a lot far better accurate estimate than our other ones. So why do they differ? They differ because we used different formulas and we used a more practical and realistic system than compared to lab 1. But we also accounted for small changes within the electric field, and therefore they were able to be evenly distributed. Thank you for watching and have a great night.